Hi everybody and welcome back to Projects with Pete. I'm your host Connor Dobson and I'm here again with Peter Milne, Linux advocate, engineer and SBC guru. So today we're going to look into PLC interfacing with Modbus RTU using the DEBIX Model A board. So before we get into the nitty gritty, let's ask some questions and we'll just kind of set up our project. So welcome back, Pete. Great to have you. So let's talk about the hardware that we're utilizing in this project. So it's the DEBIX Model A single board computer coupled with the I/O board. So together, how do these pieces of hardware serve as an ideal platform for developing a Modbus Gateway?
Yeah, well, this is the setup that I've been using, and the Model A board is on the bottom here. That's based on the IMX8 processor from NXP, which is a really popular and well-used processor in industrial boards. This one has got 2 gigabytes of RAM memory. You can have up to 6 gigabytes as an option through the design service that OKdo have, and you can also have eMMC memory added as well, up to 128 gigabytes. We've got Ethernet, gigabit Ethernet, 4 USB 3 ports, 5-volt power, on the go USB 2 port, HDMI, audio, couple of camera connectors for CSI cameras. There's a tiny little DSI connector under there. We're using an SD card on this. It's under the SD card. There's an on-off button and the reset button. And then you've got dual band Wi-Fi and Bluetooth 5 with a little connector for an external antenna as well, if you want. So it's a really well-spec board, industrial strength, really nice platform to work with. To supplement it, we've got the I/O board here that fits onto the GPIO header on the main board, and on there you've got that green connector. You've got RS485, RS232, and CAN bus connectors there, which you set with some dip switches on the board. You've got a real-time clock, battery backup. So yeah, it makes it really easy and quick to just clip it together and get prototyping for Modbus.
Sounds really cool, especially with that robust chip kind of at the heart of the board. Sounds really, really interesting.
Yeah, it's a really solid design.
Yeah, cool. What about the kind of operating systems and support that go alongside DEBIX? It's quite reliable, isn't it?
Yeah, DEBIX. It's got fantastic OS support. So you've got Ubuntu 22.04 now, and that's got the latest 6.1 kernel series. So they really keep their Linux distribution up to date. That's been updated since I actually did the write-up for this project. You've also got an option to build Yocto Linux, which is really good for custom distributions where you really want to tailor it yourself. They've got an image for Android 11 and also Windows 10 IoT, if that's what your preference is. We'll be using Linux in the project, and they've got fantastic documentation as well. They've got a website with virtually all the details that you need for working with the product, from all the specifications, schematics of the add-on boards, and simplified schematics of the connectors on the actual main board. They've got YouTube guides. They've got all the certification, user manuals, and they've also got an active Discord channel as well where you can get community support. So it's a really, it's great hardware, great software, great support. So you can't fault it at all.
Brilliant. Really reassuring to hear. Not only has it got, like you said, the great hardware and the support, but the praise about how up to date they keep their Linux from, like, a man like yourself who knows his Linux inside out is really good stamp of approval, that, isn't it?
Yeah, it's the whole package. It's what you want. It's a joy to work with, and everything works out of the box. The images all work, and you've got all the details at your fingertips. It's really good board from that
Brilliant.
point of view.
Brilliant. Good to hear that. So we'll talk about the components that we're going to be utilizing today for the PLC setup. So can you just talk us through what you're utilizing and why they're essential for the project and its success?
Yeah. So this is the PLC that we'll be using. It's a 12 to 24 volt model, and there's another variant that's 110 to 240 volts AC. What it's got 4 outputs, 4 relay outputs here. They can control up to 8 amps at 240 volt AC, and up to 5 amps at 30 volts DC. So they're your outputs. And then on the top here, you've got the power supply. That's your 12 or 24 volt, up to 24 volt DC supply. And then across the top here, you've got 6 digital inputs, so on or off, high or low. And then you've got 2 analog inputs, which can have a voltage between 0 and 10 volts. And then you've got these 2 connectors at the end, so that you can chain these together. You can have up to 4 of these in a chain linked together that are controlled. And to control them, you have to have this extra module here. This connects into the PLC, and it does 2 things. There's a programming connector which you can connect to your PC to program the PLC from software it's Windows software that you run on your PC. But we're using it as a 485 RS485 comms module. So that's the 485 bus here. And that's what we're going to be connecting to the DEBIX to do our 485 communication. And because it's this is Modbus RTU, that's a TIA/EIA standard, and you can have up to, in theory, 247 servers. The PLC is called a server. You can have up to 247 of those in theory on a single bus, and the bus can be up to 1,000 meters. So it's quite long distances that the signal can travel over. Obviously, it depends on the type of wiring and the amount of electrical noise, but you can use quite long distances, and so that's why it's a really popular industrial protocol.
Brilliant, thanks, Pete. So I imagine if you are running something like that, you need to build a test circuit to make sure everything's running as expected. So what is the significance of building a test circuit, and why is that really integral to getting it right with this project? Yeah, well, it's quite a complicated setup, and so really what you want to try and do is pare that down to the simplest, the most basic level, so that we can do set up a circuit, a simple test circuit, and then run some very basic software that we're going to write, just to make sure that we can actually switch something on and off. So that's what I tried to do in the first test. Is just I just connected an LED, 24 volt LED to the relays. So we've got 4 LEDs connected. We all love flashing lights. So we'll write a very, very short program that's going to run on the DEBIX, some Python code, just to test out that the library that we've chosen, we'll talk about that in a minute, that actually runs, and that we can actually switch the relays on and off using Modbus commands. So that's the really basic test that we're going to do. And obviously, once we've done that, we've proved that the hardware side is all working, the connectivity is working, and our electrical circuit is working.
and also our software, basic software, is doing its job. And so, before we get any more complicated than that, we know that bit's working, and we can build on that as a foundation. So if you look at any of my projects, you'll always see them build up from a very, very basic test. Just
Brilliant.
keep it simple.
Yeah, sound advice.
Yeah.
So if we look at the so the hardware, and we're looking at the I/O board, the DEBIX I/O board, what steps are involved in actually configuring that for RS485 communication? And what steps do we take to ensure that once that's all set up, that it is running seamlessly and communicating as we would expect it to?
Yeah. So I don't know if you can see it, but on here there's two tiny little dip switch.
Yep.
There's 4 little switches there, and so they configure the I/O board to either output the different protocols, the RS485, or they configure it as UARTs. You can't have both at the same time. So it's just a case of selecting the correct switches. It's marked on the board, and it's all documented in the project instructions to set the board up so that we get RS485 coming out of these two of the pins here. So it makes it really easy to do that. If you need to use the UARTs, then you can set them differently. It also on the board, which I forgot to mention, is that you've got a little USB C connector there, and that allows you to get the serial console, so you can log into the Linux terminal without a TTL to USB converter. So you can just plug a USB cable into there and put that into your host PC, and then you can see exactly what's going on the board when it boots up and stuff like that. So you've got the access to the console, and again, that's configured with the little switches.
Oh, that sounds very cool. Cool feature there.
Yes, yeah, really helpful. That's really useful for development. Yeah.
Oh, brilliant.
Makes it simple.
Cool. So so in this project, we're utilizing minimal Modbus. So how does minimal Modbus facilitate communication with the PLC?
Well, I like to use Python to do the development because it's really fast and it's much easier, for your prototyping. And if you do a search for Modbus libraries in Python, that you'll get a couple of hundred different ones. So there's loads of them out there, but there's a few that stand out. And minimal Modbus has got support for Modbus RTU. There's 2 types of Modbus. There's the stuff that runs over the serial protocol, which is the RTU, and then there's the stuff that runs over Ethernet TCP, Modbus TCP. This minimal Modbus just supports the RTU version, which is what we're using here, what we need to communicate with that PLC module. It's really well documented. It's pretty easy to use, and it's really well written, and it's kept up to date. Again, it's got a lot of people working on it, and it's used by lots of companies as well. It's used commercially. It's got good licensing. So that's the one that I chose, and yeah, it was really easy to use and worked really well.
Great, that's good to hear that it's got not only the community support, but it is kept up to date and it's being utilized. And it sounds like if you're looking for industrial reliability, that you want something kind of like that. So moving on to kind of bit more into the testing. So you touched on the project running a smoke test. So could you just explain kind of what a smoke test is and how the results of that smoke test will influence the project's next steps?
Yeah. So we talked a little bit before about setting up the circuit, and we just connected some LEDs to the outputs on the PLC. So the smoke test is a really simple program that is using the minimal Modbus library. So it's creating a connection to the port on the I/O board. So when you're communicating across RS485. It runs on a port. And you also need the address of the device which you're talking to. So each PLC has its own address on the Modbus that's part of the protocol. And, so if you've got 247 of them, they've each got their own address. So you need to know which port to send the data out on from the DEBIX and which device to send that to. That's basically the two parameters. And then also you need to set the baud rate, which is the protocol speed, the speed of the protocol. And so different devices run at different baud rates. And so they're the two things that you have to set up in the software. And then we're just running a loop really, which is sending commands. So the Modbus commands, there's a set of commands that each device can respond to. And so we're just sending a command out that says, turn the relay on, turn the relay off. Then, move to the next one, turn the relay on, turn the relay off, in a loop, a continuous loop. So the 4 LEDs on the device are going on, off, on, off, on, off in a sequence. And that just proves that we can switch them on and switch them off. It's a really, really simple test. It's just 20 lines of Python code to prove that everything works. And that's our smoke test. And once we've passed that, then we can move on to the next bit.
Brilliant. Thanks, Pete. I think that will conclude our question session for part one of this. And in part two, we're going to delve a little deeper into the project itself and what we're hoping to achieve. But yeah, it sounds good so far. And can you just give us a little kind of tidbit as to what we're going to be looking into in part two?
Yeah. So the next part of this is actually how we create a much more complicated code. That's, it's going to do the same thing. It's going to send commands across to the PLC and query the PLC to find out what state it's in. But we're going to do that through MQTT, sending requests to our MQTT broker, which we spoke about in the previous projects with Pete. And so that's the full setup. So we'll be able to send an MQTT message. That'll go to the broker. And then that will then go across to the Modbus Gateway, and it'll turn the relay on, or it'll communicate with a program which is running on Modbus on the PLC. And so that's our network fully working.
Brilliant. Thanks. Well, I can't wait for the next episode. We're going to talk about that in a bit more detail. But I think that concludes that for episode 2 of Projects with Pete. Thanks again, Pete. And stay tuned. We're going to delve a little deeper into the world of PLC interfacing via Modbus RTU in the next episode. And thanks again, and thanks for watching. And until the next time, happy hacking.
Yeah. Bye.
Bye.